guys, hello. This is your class. Hello everyone. This is your class physics class 11. That is your class is your 25. We'll be continuing with the unit third, which is motion in a straight line. So unit third is motion in a straight line. So we'll go for it. Here we go. So for the same, we'll discuss about additional exercises here. That is your in terms of additional exercises, we had done 22th question for your here in a motion in a straight line, where we had completed unit 1, that is physical world, and unit 2, units and measurement. In the same way for the units 3, that is a motion in a straight line, which we will be covering here. So in additional exercises, the 23rd question, we have a three-wheeler starts from rest, accelerate uniformly with 1 meter second inverse squares on a straight route for 10 s, and then moves with uniform velocity. Plot the distance covered by the vehicle during the nth a second, which is n equals to 1 2 3, and that is versus n. And what do you expect that plot to be doing? Accelerated motion, which is a straight line or a parabola. For the another question, we have 24, that is a boy standing on a stationary lift open from above, thrown a ball upward with the maximum initial speed he can, equals to 49 meters second inverse. How much time does the ball take to return to his land if the lift starts moving with a uniform speed of 5 meters second inverse, and the boy again throws the ball up with the maximum speed he can? How long does the ball takes to return to his handle? Another 25th one, which we have on a long horizontally moving belt where a child runs to and fro with a speed 9 km per hour here, and with respect to the belt, so between his father and mother, that is located 15 meters apart on the moving belt. The belt moves with a speed of 4 km per hour. For an observer on a stationary platform outside, what is the speed of the child running in the direction of motion of the belt? The speed of child running opposite to the direction of motion of the belt, and time taken by the child in here 1 and B, which of the answer alter if motion is viewed by one of the parents here. So that has been the moving belt here, 4 km per hour, and the child is here, and the stationary observer has been seen. On the same way, the another question we go for it, that has been the another important one. Two stones are thrown up simultaneously from the edge of the cliff 200 meter high with the initial speed of 15 meters second inverse and 30 meters second inverse. Verify that the graph shown. So here that correctly time variation of the relative position of the second stone here with respect to the first. Neglect air resistance and assume that the stones do not rebound after hitting the ground. Take g equals to 10 meters second inverse square. Give the equation for the linear and the curved part of the plot here. Now we talk about for another one, which has been the another important question here, and that we have as follows. So here we go for it. First we'll go for the question here. Eight, 10, 12. Respect to t of second. Here it will be 20, 40, 60, 80 and 100, 120, which is in x2 minus x1 meter. So it will start from here, then it will draw from here. So now we'll talk about for another question. The speed time graph of a particle moving along a fixed direction that is shown. Obtain the distance traversed by the particle between a t equals to 0 to 10 seconds and b t equals to 2 seconds to 6 seconds. So we have so here it will be speed meter second inverse. This is 12, 0, 5, 10. So here it will be that we have. Now another question is, you have in this question you have to find out what is the average speed of the particle over the interval in A and B. Now we have to find out the another question, that is the velocity time graph of a particle in a one dimension motion that will be shown. For that it will be so here it will be, this is T2, this is T1 and 0. So for that, which of the following formula that are correct for describing the motion of a particle over the time interval t1 to t2, where x t2 equals to x t1, v t1 t2 minus t2, and that is all we'll have to find out here. Now we'll talk about the elements of calculus. That is differential calculus. In differential calculus, here you have to using the concepts of differential coefficient and derivative. We can easily define velocity and acceleration, though you will learn in detail in mathematics about the derivative. We shall introduce the concept in the brief appendix so as to facilitate its use in describing the physical quantity that involved in motion here. Suppose we have a quantity y whose value depends upon a single variation. On the same way here we'll discuss about it. So that describing the physical quantity that is involved in motion. Suppose we have a quantity y whose value depends upon a single variable x and its expressions by the equation defining y as some specific functions of x. So this is represented as here, which is y equals to fx. This relationship can be visualized by drawing a graph of function y equals to fx that regarding y and x as Cartesian coordinate that being shown here. So we'll just made a graph here. So this is y plus delta y, this is for y, x plus delta x, and then x it will be. So the graph will be goes from it will be here. From these 2 points it will be cut. this is the point Q, P, X comma Y. The Q point is X plus delta X, Y equals to Fx. This is delta Y. That is a drop here. So we have another graph. X. This is Y. Here it will be Y. So X, Y. This is it. So here you have to consider the point P on the curve y equals to fx, whose coordinate are x comma y, and the another point Q where the coordinates are x plus delta x, y plus delta y. The slope of the line joining P and Q is given as here. That is tan theta equals to delta y upon delta x equals to y plus delta y minus y upon delta x. Suppose now that the point Q moves along the curves towards P. In this process, delta y and delta x decrease and approach 0, though their ratio delta y by delta x will not necessarily vanish. What happens to the line PQ as delta y tends to 0 and delta x tends to 0? You can see that this line becomes a tangent to the curve at a point P, where this means that tan theta approaches the slope of the tangent at P, denoted by M, which is equals to limit tends to 0 delta y by delta x, limit delta x tends to 0. The limit at the ratio delta y by delta x as delta x approaches 0 is called a derivative of y with respect to x and is written as dy by dx. It represents the slope of the tangent line to the curve y equals to fx at the point x comma y. Since y equals to fx, y plus delta y equals to fx plus delta x, that we can write the definitions of the derivative as point x comma y. So here we go for dy by dx equals to dfx by dx, limit x tends to 0, where delta y by dx equals to limit x tends to 0, x plus delta x minus fx over delta x. Given below are some elementary formula for the derivative of the function here, and in these here u of x and v of x represent arbitrary and functions of x, and a and b denote constants quantities and that independent of x. Derivative of some common functions are also listed here. So we go for another one which we'll be talking about. So here we go for the derivatives. So d of au by dx equals to a du by dx. Another one is du by dt equals to du by dx dx by dt. ub upon dx equals to u dv by dx plus v du by dx. So for the same it will be, so for the same we go for it here, du by v by dx equals to 1 by v square, du by dx equals to u dv by dx, du by dv equals to u here du by dx by dv by dx here. So here we go for it and we will discuss about that. D by dx here, it is your sin x equals to cos x. So d by dx cos x equals to minus sin x. Now d or dx tan x here. So d by dx tan x equals to sec square x, d by dx cot x equals to minus cosec square x. Then we have your d by dx sec x equals to tan x sec x, d by dx equals to cosec square x, it will be equals to minus cot x cosec x, d by du dx u by n equals to nu n minus 1, du by dx d by du u equals to 1 upon u, and d by du e of u equals to e power u. So in terms of derivatives, instantaneous velocity and the acceleration that are defined as, which is being u equals to limit delta t tends to 0 delta x by delta t equals to dx by dt here. So a equals to delta t tends to 0 dv by dt equals to d square x upon dt. So here we go. So in the same way, where for the integral calculus we talk about it. In terms of integral calculus, here that you are familiar with the notions of the area and the formula for the area of simple geometrical figures that are also known to you, and for example that the area of rectangle in the length times breadth and that of triangle is half of the product of base and height. But how to deal with the problems of determinations of area of an irregular figure, the mathematical notions of integral is necessary to the connection with such problems. Let us take to concrete an example. Suppose a variable force Fx acts on a particle and its motions along x-axis from x equals to a to x equals to b. The problem is to determine the work done W by the force of particles during the motion This problem is discussed here in the next coming detail chapter, and that the variation of fx with x if the force over constant work would be simply the area FBA as that shown, and but the general case forces varying here. So we go for it. Here we go. So here for that, 0, this is x, this is f of x, a and b, f. For another one, x, f of x, 0, the graph is like this. This is x 2 minus is x1. So this has been the A point, which is x0, and xn, which is B point. So to the calculus the area under this curve, let us simply following the trick that divide the interval on the x-axis from A to B into a large number of n of the small intervals, which is x naught a and to x1 and x1 to x2, x2 to x3 till xn minus 1 to xn, that is being equals to b here. So the area under the curve is thus divided into n strips, and each strips that is been appropriately a rectangular, and since the variations of p of f of x over a strip is negligible, the area of the ith strip that is then appropriately, and for the same we go for it. So delta ai equals to f xi and xi minus xi minus 1, which is equals to f of xi and delta x. So where delta x is the width of the strip, which we have taken to be the same for all the strips, you may wonder whether we would put f x that is t minus I minus 1, or the mean of fx and fx minus 1, so that the above expression, if we taken n to be the very large, which is n tends to infinity, it does not really matter, since then the strips will be so thin that the difference between fxi and fxi minus 1 is variously vanishingly small, and the total area under the curve then it is will be in the form a equals to n I equals to 1 delta ai equals to n I equals to 1 f xi delta x. So the limit of this sum as n tends to infinity is known as the integral of fx over x from a to b, and it is given a spatial symbol as that shown, which is being your a equals to b to a fx dx that we have. Here the integral sign, this that look like an elongated s, and remaining as that is basically as a limit of the sum of infinite numbers of terms here on the terms. And a most significant mathematically fact, that is that integration is in this case as inverse of differentiation. Suppose we have a function of gx whose derivative of f of x, that is fx, is your dgx upon x, where the function of gx is known as an indefinite that is integral of fx, and is denoted by g of x equals to f of x dx. So on the same way, here an integral with the lower and upper limit, that is known as definite integral, and it's a number. Indefinite integral has a no limit, it is a function. A functional theorem of the mathematics status that been upon here. is a to b, fx dx equals to g of x b of a equals to g b minus g of a here. As an example, let's suppose fx equals to x square and we wish to determine the value of definite integral here from x equals to 1 to x equals to 2, and the function gx whose derivative is x square is x cubed by 3. Therefore, here we go, which is 1 by 2x square dx. So on the same way here, for x square dx equals to x cubed by 3 from 1 to 2 is here x by 3 minus 1 by 3, which is equals to 7 by 3 here. So that's what we'll have, and clearly to evaluate that definite integrals here, and that we need to know about the corresponding indefinite integral, some common indefinite integrals that we have here, which is very important as well, and that what we'll have to discuss here. So here we go for the same. So the first integral is xn dx is equals to xn plus 1 upon n plus 1, where n does not equals to minus 1. Another is f1 by x dx equals to L log x, where x is greater than 0. Another is sin x dx equals to minus cos x, where cos x dx is equal to sin x. Another is ex dx equals to e of x. So this introduction to the differential and integral calculus is not rigorous and is intended to convey to you to the basic notion of the calculus. Yeah, so we're gonna end up with this only, and we'll discuss the rest of the class. We had end up with unit 3, which is your motions in a straight line. We'll discuss the another one, which is motion in a plane, and that we'll discuss in the next coming classes, that is of 26th class of the session. Other than that, if I'm talking about here, so yes, we had done your chemistry part 1 for class 11, chemistry part 2 for class 11. We are dealing here, we had dealing with the quantitative aptitude, where we had started with arithmetical ability, and that we had done your 16 topics, and after that we are dealing with, we had done your reasoning. This is your verbal reasoning and the verbal non-verbal reasoning which we had done. Coming towards physics here, where we had done your chapter 1, which is your physical world. In that we had done what is physics, scope and excitement of physics, physics technology and society, fundamental forces in nature and nature of physical law. The second is your units and measurement, which is your introduction, the international system of unit, measurement of length, measurement of mass, measurement of time, accuracy, precisions and instrument and errors in measurement, significant figures, dimensions of physical quantities, dimensional formula and dimensional equation, dimensional analysis and its application. Unit 3, which we have to cover up, is your motion in a straight line, which is introduction, position, path length and displacement, average velocity and average speed, instantaneous velocity and speed, acceleration, kinematic equation for the uniformly accelerated motion and relative velocity. Unit 4 is your motion in a plane. Unit 5, which we have here, is your that is laws of motion. Unit 6 is work, energy and power. Unit 7 is system of particles and rotational motion. Unit 8 is your gravitation. So we're gonna end up with, thank you, hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Please like, share and subscribe our channel, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Thank you.